Hey, what's up guys, my name is the Cherno. Welcome back to my game engine series. It's been a while, but we are back, and today we've got a bit of an exciting episode because we're going to be talking all about gizmos. Last time, I think we did like serialization stuff. Check out the video linked up there. And today, as I mentioned, is going to be all about adding in some kind of manipulation gizmo so that we can actually like translate, rotate, and scale entities and their transforms inside our scene by using like an on-screen gizmo, like much like what you would see in any other game engine or like Unity or Blender or any 3D program really. So that is what's up. Yeah, you guys can say hello YouTube. It's been so long, you know. I do want to mention quickly that I stream a lot of my development for both Hazel Dev and this game engine series version of Hazel live on twitch.tv/thecherno. That's where I'm streaming this right now. But also, you know, as this series gets more complex, as we kind of begin to, I guess, go deeper into this game engine, and obviously it's going to get to a point where it's going to be harder and harder to actually, I guess, you know, work out the code that needs to be written and solve these problems. This series is not going to contain me trying to work out problems, right? This series will be me kind of showing you the solutions that I come up with, obviously, and how I solve those problems. The process of solving the problems, mostly, I stream live on Twitch. So if you're interested more in seeing how I even come up with these things or how I decide how to implement certain features, then following along with my Twitch live stream, and looking at past broadcasts or supporting me on Patreon so that you can get access to the whole library of past broadcasts is probably a better, a good thing for you to do, essentially, because it'll obviously showcase a lot more of kind of leading up to the solutions instead of just presenting those solutions in their final form, which is kind of what this is about. That's kind of my little disclaimer out of the way. And today let's talk about how to actually get gizmos in, and I'll show you basically what I've done. And this is going to be the result of what I've spent the last couple live streams thinking about and implementing. So if we take a look at what we've got so far, there were some pull requests that did make it in. I'm not going to discuss them today. Some of them are not that great, and we might talk about them later. And I might have to revert some stuff, but it doesn't matter. For now, what we've got is basically this hazelnut editor. And if I try and open a scene here, we've got like this 3D example. And the reason it's called a 3D example is because the camera, I think, is a perspective projection camera. What I've added, right, and copied and pasted, is this pinkcube.hazel file. I'll commit this at the end of this episode, so you guys will also be able to see it. But basically, pinkcube.hazel is this lovely little pink cube that I made during a live stream. And I think this was actually while I was planning serialization before I actually recorded those episodes. So definitely, you know, take a look at that and pull the latest code so you can see this stuff. And this is kind of going to be our starting point for Gizmos, just because this is going to be able to showcase it a lot more. So basically, what I want to do today is I want to be able to select top, right, and left. You know, camera doesn't really matter too much, but as I click on these entities, right, I want to be able to, you know, bring up a gizmo around the origin of where that entity's like pivot point at least is, where that transform is essentially in 3D space, which doesn't have to be exactly in the middle of all the vertices, obviously, because the vertices can be completely offset, but wherever that transform is, which in this case is in this world space position, I want to have a gizmo pop up, obviously. I want to have translation, rotation, and scale so that I can modify the translation, rotation, and scale using an on-screen gizmo as I select these. Now, we're not going to be doing mouse picking today. That's a completely different story. It has nothing to do with gizmos. Today is just going to be all about gizmos. So how do we do this? Well, you could write your own gizmo library. I'm not going to do that. I actually had a bit of a rant on this live stream earlier today about using third-party libraries and how I, not necessarily how I decide which ones to use, but, you know, what I think about the whole process of using third-party libraries. Tarek, thank you so much for your Prime subscription. Does that still, that doesn't show up on the screen, does it? I'm sorry, it should. It's just, I guess, because there's no chat, maybe? Anyway, whatever. Sorry, well, we'll fix that for the next episode. Tarek, shout out to you. Anyway, so, what was I saying? Yeah, so, you know, regarding like third-party libraries and all of that, We'll save that for a different day, but ultimately I'm going to use a third-party library called ImGuizmo, which basically integrates really well with ImGui to actually render these gizmos. Now, the default look and feel and usability and the way that that library works is not perfect, I think. Well, at least for what I want and for what I would like gizmos to be like in Hazelnut and in Hazel, excuse me, they are like, it doesn't like, I've made some modifications to it basically to make it a little bit better in my opinion. So what I've done is I forked it. This is the fork, and as usual, we're just going to add it as a submodule. I've forked it. I have not added pre-make to this, right? But I have forked it, and if you look at, I guess, these latest, like this latest commit, you can see I've just tweaked a few things here just to make it look and feel a little bit better. So that, and I don't know, like this might need some revision or whatever, but I've just changed the look and feel of it a little bit better, because I think it looks a bit nicer, and I've changed tweaked the colors and just minor additions, but mostly it's just the ImGuizmo stuff. And this is just something that's been in Hazel Dev for a while, so we're going to be using that existing code. So the first step is going to be to actually add this as a submodule. So I'm going to go into the root of my repository here, and I'm going to, as usual, just do git submodule add, and we're going to add that. Now, I never remember the path of it. I guess the path comes after that. But basically, Hazel and vendor, and then I guess just ImGui, right? ImGuizmo. So Hazel, vendor, and I think I can just not type in a path. I do. Sometimes you have to. Sometimes you don't. Like that. There you go. So we've added a submodule. And again, I'm not going to compile this as a separate module. I'm just going to compile it into Hazel because I don't know, like in my opinion, I think it's like, realistically, I think it's like 2 files. So what, like, I just don't think that's worth making like a static library out of. So what I want to do, and I'll be referring to like my diff of what I've already worked out during the live streams for all this stuff, just to speed this process up. Otherwise this episode would be probably a couple hours long. So what I'll do is I will find the, inside Hazel, let's find the pre-make file, and I'll see what I've done here. So basically all I've done is to the compilation here, just like we did with GLM. I mean, this isn't really to the compilation, it's more like to the project. I'm going to do the same thing here, but add the ImGuizmo stuff. So ImGuizmo was the directory. And then I think there's, again, as I mentioned, 2 files. There's the header file and there's a CPP file. No need to add the examples or anything like that, even though they're included. We can just keep them still there for reference code, but we don't need to compile them. So we'll just add ImGuizmo like that. And then as far as the include directories go, I'm going to specify the include directory. And I think the include directory, we usually specify like the list of them here, right? So when we have all of the include directories in the pre-make file that is inside the root of our project, I'm going to add this. So we're going to do Hazel vendor, ImGuizmo, and I believe that's it. I think it's just there. There's no include directory, right? So that's kind of it, I guess. We've included these, and then finally, in order to be able to use this, we'll also add ImGuizmo as an include directory. And then finally, the last thing I want to do that it will stop, well, it'll enable us to actually not modify the files themselves, is we have to deal with our precompiled headers, because obviously every CPP file that is marked as using precompiled headers has to include the precompiled header as the first include. ImGuizmo is not our code, technically. I mean, I've modified it, so I could have added the include, but I don't want to. So because it's not going to be using any of Hazel's code anyways, it's like a separate module. So what I'm going to do is probably over here, I'm going to add a little filter specifically for a file. So you can do files, vendor, ImGuizmo, and then basically any CPP file in that directory or any subdirectory. So I've added that filter, and then what that's going to do is I'm going to create a flag that's called no PCH. That will mark the file as not using PCH, right? So in other words, if you go to like maybe that's a bad example because that is the PCH, but if you go to like this, for example, and you look at the precompiled header, you can see this is marked as use, not using precompiled headers, right, is what that will do in Visual Studio. only for that file or only for any CPP files there. So therefore we're going to compile without any issue. That's it, I think. So if we go into scripts and we rerun the generate project script and reload it, should be able to see ImGuizmo, and we'll control F7 just to test that out. It should work. Okay, so there we go. We've now got ImGuizmo. I don't know, ImGuizmo, whatever. We've got our gizmos. So we're going to go into the ImGUI layer now and talk about how we can actually render them and how we can use them. API is very simple. I really like the library, by the way. I mean, like, as I meant, I may have been harsh with my, I fixed some things in it. I didn't really fix things. I just changed the style to suit me more and to suit what I want it to look like more. But props to the author, because I think it's a great library. It's quite well written. And it does a lot of math stuff that I would not want to be scratching my head over, for sure. Okay, so inside ImGUI layer, I'm going to include ImGuizmo because we basically have to call something at the beginning of each frame. After we start the ImGUI new frame, what I want to do is call, which is actually here, I want to call ImGuizmo begin frame. Because again, it taps into ImGUI code, which is great because it's part of like our UI, which is the gizmo, so it should be. I don't want to like, you know, it's really nice to have it tie into ImGUI's draw list and all of that stuff. Like, that's really nice because it just ends up being part of our UI pass instead of being like some kind of separate OpenGL rendering thing. So I quite like that. Also means it's quite efficient because ImGUI obviously batches everything together, and it is rather efficient. So now that we've done that, right, all we have to do is basically use the gizmo now. So if we go back to our editor layer, which of course is like our layer where we draw the viewport and do all of the fun stuff, what I want to do is actually start drawing the gizmo. So if we go over here to our viewport code, and it's probably worth bringing out maybe some of the viewport stuff because this is going to be quite annoying. But basically before we end, because we obviously want to draw it in the viewport, we're going to do our gizmo stuff here. So I'll just add a little comment called gizmos, zoom in a little bit. How's chat doing? Everything fine? Yeah, that's good. Sweet. Sometimes I like to check in on chat a bit because when I start recording these episodes, I just get lost in my own little world as if I'm recording a video and not even live streaming, but I am live streaming. So the important thing for us now is to select an entity, right? Like we want to know what is the currently selected entity, because obviously that entity's transform is what we're trying to control. So how do we get the currently selected entity? And I'll just call this selected entity. Well, that's where our API falls apart, because at the moment, we basically need to ask the scene hierarchy panel, hey, what is your selected entity? Now, whether or not that should be like that is debatable, because in the future, when you, for example, mouse pick to select entities, that doesn't really involve the scene hierarchy panel. You need to tell the scene hierarchy panel, hey, I've selected this entity, so please display its properties selected in the tree, all of that stuff. But at the moment, our only source of selection that exists in this whole thing is inside the scene hierarchy panel, so I'm adding this here. The way it works in Hazel Dev is there's basically a series of callbacks, right? So every time you select something in scene hierarchy panel, you can kind of subscribe to that event and receive a callback when the selection changed. So it's also kind of like an on selection changed event. And then vice versa as well. You can tell the scene hierarchy panel, hey, I selected this entity. So it always should work both ways, because there's obviously going to be cases for both of these things to work. This is annoying. This is probably another pull request. Might deal with that later. Okay, so, and this is really easy because we have a selection context. So really all this becomes is entity get selected entity. I'll make this a const function and we will return that. And thank you, Visual Studio. Okay, so that's done now. We have this get selected entity function. We know what we've currently selected. Now, rule number one is anything selected? So obviously we can just check that with a simple if statement. Is this a valid entity or is it not, right? So if it's a valid entity, so it exists, it's not zero, it's not like no entity, we can actually start setting this up for drawing. So in terms of ImGuizmo, we basically need to set orthographic to false. We will be setting this to true in the future for orthographic projections. The first step, and what we're going to do today, is make it work for perspective projections, just because that's a little bit easier to know what we even want to do in the first place. And let's also obviously include ImGuizmo. ImGuizmo. You happy? No, you're not. You know why? Because this is hazelnut. So let's go back to pre-make and add this as an include directory into, excuse me, into hazelnut's pre-make file. I don't even know if that was like in the diff. don't think I noticed that. There you go. So it's not completely scripted. All right, so now we should be good. Unfortunately, it's reloaded everything, so I don't know where I am. Here I am. I'll set orthographic to false, and then we'll do ImGuizmo set draw list, right? Which I think, you know, you just call it before manipulate to draw Gizmo to that window. That's it. And then we need to set basically like the viewport, so set rect. And this is where things are going to get interesting. So we want to basically get from ImGui, get the window position. I'm not 100% sure what the best way to do this, because I don't know, like apparently in my diff I've written it as get window position Y, and then I've also got the window height, so window width is ImGui get window width. But like I've used get available content area before, or get available content region, or whatever it is in ImGui. Sometimes the API for ImGui can be a little bit all over the place, just because they seem to have a bunch of functions that do the same thing, but maybe they don't. Maybe they include padding, maybe they include like little title bars. So I'm not sure, like this not guaranteeing this to be perfect, but it should be okay for now. So we're setting the rectangle now. This is like, excuse me, coughing a lot today. Setting the, like the viewport in a way. And then we need to basically draw like the gizmo, and to do that we need to basically work out like where the camera is, right? Because obviously the camera is going to define how we render this. We have to set the view projection matrix basically. And then also get the transform from the entity, which is kind of the easy part. Now the camera part, that's where it's a bit tricky. At the moment, we don't have a camera. We don't have an edited camera. We've only got like a runtime style camera, which is really a camera component, right, on an entity. So we need a way to get the active camera, right? So what I did for this is I basically was able to retrieve the camera entity by adding a function to our scene, so to our currently active scene, and I called it get primary camera entity, which might seem a bit Dogecoin, and I don't blame you if you think that, but I don't think it's that bad. Basically, this is a bit of a convenience function to just be like, hey, get me the primary camera, and specifically the entity that the primary camera is attached to. So the way that that's implemented is quite simple. We just simply create a view, so registry view with our camera component, and then we cycle through the view, because remember, we're not just looking for the camera, we're looking for the active camera, for the primary camera, because we can have more than one camera in the scene, but only one obviously is being rendered at once. So we'll iterate through that. We'll retrieve the camera, which is actually like, actually, no, this is the camera component for the current entity. So let's maybe make that a reference, const reference maybe. And then if primary is set to true, we'll just full on just return it. So we'll have to construct a Hazel entity out of it, which as we know is just the entity ID and the current pointer to the scene, which is our context. Otherwise we'll return just an empty entity. That's it, easy. So now if we go back to editor layer, we should be able to get the primary camera entity, which of course is the case. So next step, so this is us trying to get our camera. The next step's going to be to, well, let's get the camera component from this, right? So now that we've got the entity, let's get the camera from it. So get component, camera, components. I hope our camera has everything we need, by the way. I haven't really checked. But basically what we want to get is the camera view matrix. Because that's what well, no, actually the camera view is going to be the inverse transform of the camera. So the transform components transform the inverse of that. So actually, this is going to be GLM inverse camera entity dot get component transform component get transform. Speaking of which, I think there was one thing that I wanted to adjust here. At the moment, we're kind of actually creating the matrix like that, right? But I think there's a better way to do it, an easier way to do it with the API, because I changed it to that. So I think all you really have to do for rotation, instead of doing this, is just do GLM to mat4 from the quaternion, I think. And you can create a quaternion from those Euler angles, like that. So that just looks a bit cleaner, right? There's our rotation. And I think for that, we do need to include some, maybe this wasn't a better solution, but we'll need them anyway. So we'll include the experimental stuff, because we'll be including something from GTX, which is like the experimental stuff. So GLM, GTX, quaternion. Quaternions are experimental. So, I mean, you know, it doesn't really mean it's like dodgy or anything. Okay, done. So next step is, now that that was just a bit of a side thing. But anyway, we've got the camera view. The camera projection, though, we should be able to pull out from there. And I think that's just going to be camera get projection, which doesn't exist. So see, this is what I mean. I might have to... Oh, actually... Nah, it does exist. Good. Might as well get the camera here. That just avoids this. So GLM mat4, and is that a... What does that return? A const. Okay, sure. So const reference camera projection. So we've got the camera projection. We've got the camera view, right? So now we've got everything we need basically to render. So let's get the entity transform now. So from the selected entity, we can get the transform component. And I guess we'll just do GLM mat4 transform equals TC dot get transform. Okay, so that's using the function that we just basically modified a little bit to add the quaternion mat4 thing. All right, hopefully that's not slower than what than the code we replaced, but it looks cleaner, so that's why I went for it. Okay, so now, I mean, there's some other stuff that I've got here that we'll add later, like snapping, but, you know, for now, we'll just do ImGuizmo manipulate. So basically, long story short, we set the orthographic to false because, well, you don't need to do this every frame, I don't think, but we're doing it because we might alternate between orthographic and perspective based on the camera, obviously. We set the draw list so that it draws the current window. We set the rectangle, that's our viewport, and then we call manipulate. This is just us getting the data we need for the manipulate function, which is what actually is going to deal with, and render our gizmos. So we want to do GLM value pointer. The first parameter, as you saw, was the view. So we'll pass in camera view. We're just doing value pointer because this wants a float pointer. Then we will do the same thing for the camera's projection. So camera projection, right? Then the next step is the operation. Okay, so for now, we're just going to do ImGuizmo operation. Let's just do translate. Okay, but we will obviously keep track of this, and we'll be able to switch this up to, you know, rotate and scale based on like a hotkey. So the mode local is pretty much all we're going to do for now. We want to be in local space. And then the matrix is going to be the whatever we're trying to transform, right? So our transform matrix. So we'll just pass in transform. After that, we've got a bunch of other stuff like the delta matrix, which we don't really need for this, and snapping, which we'll leave off as well. That's it. Okay. So if something changes here, what we're going to have to do, right, is reconstruct this matrix now. So we've obviously, inside our component, we store these separately. So we convert it into a matrix, ImGuizmo manipulates it, and then we need to decompose it back into the individual deconstructed matrix things, so translate, rotate, and scale. So we'll do that in a minute. Let's just see if this renders anything. That would be nice. How's stream doing? Just talking about other stuff, that's cool. Okay, so let's go to our pink cube. And it's already failed. Oh, that's because this was wrong. So if you actually look at this, I think that this should have been 0 and this should have been, was it 45? I don't remember what it's supposed to be. Oh, and this should be 0. No. How do I get it to be, oh, maybe they both are 45 or something like that. I don't remember, I'm trying to hack this. Oh, there we go, 90 and 45, there we go. So it's just because our rotations were in the wrong order before, so let me save this as the pink cube. Why don't we have a normal save? Anyway, whatever. So now you can see beautifully, right? Whatever I select, we see a beautiful gizmo, right? Top, camera you can't really see it because we are the camera. That's what we're looking through now, right? Oh, that was a bad move. You didn't see that. We'll deal with that later. So yeah, whatever we select, we see a transform, and most importantly, you can see it's at the origin of this mesh, right? Of this, actually it's a sprite, but it's like, you know, it's a vertex. It's a piece of geometry, right? It's at the center because we know that our coordinates are from -0.5 to +0.5, so this should be in the middle. And obviously the camera's projection and everything is working properly because we see it in the right place. Now, if we try and move it, it's not going to move anywhere because we're not doing anything yet, right? That's where the next step comes in. So let's do translation first because it's easy. So technically this whole thing is easy, right? Because once we've got this transform matrix has been modified. So we can just do a little check first because remember, this runs every frame. This manipulate function doesn't just manipulate our transform, it also renders it. So we need to know whether or not it's actually been used because otherwise we don't want to be continually decomposing and setting our matrices and all of our transforms if nothing's changed. So there's a nice little isUsing function, and if using is true, that's when we want to apply the changes. So what we'll do is, well, for this is the easy case, right? For our translation, this is as simple as just getting from the transform, right, the last column. That's going to be a vec4. Can I just cast that to a vec3? Probably, like, is there a constructor that takes that in? Maybe I can just do that. We'll see if that works. Yep. Okay, so now you saw that was really easy, obviously. Keep stressing that. Magic, right? Look at that. Everything works, right? Well, not everything, but translation works perfectly fine. I can move this wherever I like. Let's maximize this, make sure it still works. It does. I can move this wherever I like, select something else, move this wherever I like, and you can see that it works beautifully, right? That's exactly what we want to see. And then the left one as well, right? Okay, great. So that obviously works. Now, how do we do it with rotation and scale? Well, different ball game. A little bit more complicated than just this. So scale is easy. Scale is just the length of the diagonals, length of those vectors. So that's pretty easy. But then we have rotation, which is a bit harder. Now, the thing is, GLM actually has a function called decompose, which takes in a matrix and gives you a whole bunch of stuff. And I mean a whole bunch of stuff, right? It gives you the scale, the orientation, the translation. That's what we're after, right? But then also the skew and the perspective, which we're not after. And furthermore, if you look at this function, which I did during the live stream, there's like to do, fix me, and I noticed that sometimes this just returns false, which means none of this actually works. Not to mention that it does a whole bunch of stuff like tries to figure out the perspective, and, you know, runs like inverse functions and does a whole bunch of expensive stuff that we don't care about. So I took the liberty of copying this function and stripping out everything that I don't care about and just keeping the stuff that I want. So I got rid of skew and I got rid of scale, and I also changed the quaternion orientation, which is this code, to just be their kind of commented out Euler angle one, because that's at the end of the day what we need anyway. So if I use this version, I would have had to have converted into Euler angles anyway, right? And I came up with my own little decompose function, which I'm going to copy and paste and then kind of go through roughly because I'm not going to type it out for you. But if we go into Hazel, make sure we're in show all files mode. Inside source Hazel, I'm going to add a little folder called math. And inside there, I'm going to add a header file, also called math. And this is just kind of generic because we don't really have a math library. We'll include, no, I've ruined everything. Gotta reshoot the whole episode. So this is just gonna be a bunch of math functions basically. And we could hide this behind a math namespace or something like that. I don't really care. Maybe I do. Hazel math, maybe. Maybe, because it's not, I'm not planning to put this, I didn't do this during the live stream, but maybe I'll add a little math namespace, just to hide it behind that. But basically, this is going to return the same thing as the GLM one. I'm just going to call it decompose transform, right? Because it's not going to do anything with perspective or, you know, anything like that. It's just going to be translation, rotation, scale, which is a transform. So I'll take in a GLM mat4 transform, and I will take in a vec3 translation, and this is what we're outputting. So this is like our out translation. I guess I'll call it that just to be completely obvious. Rotation / orientation, kind of the same thing in this case, and scale, out scale. So that's kind of what it looks like. Nice big function, and then we're going to implement it in a CPP file. So let's grab this, math.cpp, include our PCH, include math, namespace Hazel math. Guess I'll do that. And then we'll copy and paste it from my diff. So let's grab that. All right. I left this in here because I'm not sure if we ever need this. And I didn't bother actually working it out, but we'll do this here. So you need to include the whole matrix decompose thing also, which is this. Let's talk about this briefly. So what did I do? Well, I left a comment saying what it's from, just in case someone needs to fix it or change it. I added it using namespace GLM, so that because in their code it assumes that, and I didn't want to add GLM everywhere inside this function, and also did using t equals float, because originally it is a template function, which runs, I guess, for like a different amount of different data type or different, I don't know, like it's templated, but we don't really need that. So I just kind of added a using t equals float here because we're going to be using it with floats, just so that I wouldn't have to replace t absolutely everywhere, as you can see in this function. But ultimately, I just stripped the stuff I didn't need, and as I mentioned, uncommented out this rotation code. That's it. Really simple, and it should be a lot faster than their matrix decompose as well, because obviously theirs does a lot more, and it's not cheap, some of the stuff that it does. So yeah, anyway, that's that. So now in editor layer, I will include Hazel math, right? And the idea here is, instead of using this translation like this, we could do that, but we'll be a bit more obvious. We'll do math decompose transforms as Hazel's math function now. Transform will be the transform, and then we have GLM vec3 translation rotation scale. Translation rotation scale. Now, by default, these won't be initialized, obviously, so just keep an eye on that. But this should set all of them, as far as I'm aware, because it might return here, in which case it doesn't set all of them, but otherwise it doesn't return. Whereas the GLM one returned in a bunch of places, and that actually had me stumped a few times. Anyway, so now we set translation to this translation, which again is the same, it's just more of a convenience thing, but we also have rotation and scale. Now here's the thing with rotation. If you just get the rotation from the matrix, you can easily wind up with gimbal lock. Really easy way to fix that, as far as I'm concerned, is to just apply rotation as a delta, right? So instead of because that way you're always just adding something, you're never going to wind up with something being locked because of like an equation, because you're always just adding an angle. So to do that, we basically need to store the original rotation, which is easy because our transform component already has it, right? So when we get our transform component here, right, we can just do glm vec3 original rotation equals tc.rotation. Easy, right? And in fact, if you really wanted to, I guess you could do it here because the transform component hasn't been set here. And then we can do, actually we can just do delta rotation, which is going to be our decomposed rotation minus the transform component's original rotation. That's our delta rotation. And then we can just say rotation plus equals that delta. Okay? This is perfect. No gimbal lock, no nothing. Everything will work as expected. Okay? Finally, scale. tc.scale equals scale. And that's it. That is our whole Gizmo situation. Now the only thing I would love to do is be able to change what Gizmo is currently active. So let's see how we can do that. Now this stuff, honestly, we could store this as just an int, I guess. So if I go over here and I'll do int Gizmo type equals -1, which means no Gizmo, right? Because translate is 0. Rotate and is 1, scale is 2, and there's also this bouncing which we're not using, which is 3. But if we just replace this with ImGuizmo type and we cast this to an ImGuizmo operation, we can also have that kind of none type, which is -1. So we only want to draw the gizmo if the selected entity exists and gizmo type does not equal -1, right? So if it's actually a gizmo, let's draw it, right? So the cool thing here is that if I now want to, you know, look at the rotation gizmo, which I think is number 1, right? Well, actually, what I should do is actually use the enum, eh? So, rotate. Let's see if that works. I should probably just have it load the cube by default. There's our rotation gizmo. Should be able to rotate stuff now, and you can see I can. And everything seems to work perfectly, and you can watch the rotation obviously over here change. Now you might notice something if you're looking closely here. These never go past the kind of -180 to +180 range. The reason is that with a rotation, obviously 0 degrees is the same as 360, it's the same as 720, etc. Right? You kind of have this situation where to solve a rotation equation, obviously like there are multiple solutions, I mean, hopefully that makes sense, right? So a lot of engines and 3D programs, like I think Blender, Unreal, and Unity all have this kind of concept of a rotation that is past that range. So you can have a rotation of 1,000 degrees actually show up here and it will make sense. And you can see that technically speaking, if we do this ourselves using this, it's going to work, because at the end of the day, remember, this is just a vec3, right? So you can see we have 1,000 degrees. But what happens now if I start rotating this? Well, technically this is equal to about, well, that was equal to like about 0 degrees or whatever. But you can see in general that this also is the same as that -360 degrees, -360, -3, whatever. So if I start rotating it now and you watch this value here, right? This all works as expected. You can see nothing weird happens with the rendering, but suddenly this is snapped down to 25. Now, whether or not you want to keep it this way is, I think, up to you and your engine. I think this is fine because fixing this problem, as far as I'm aware, is kind of a complex issue. And I was not able to come up with an easy, straightforward solution. I think what I've written here is quite straightforward. So I'm going to leave it as is for now. Programmatically, it doesn't matter, because that rotation is going to be identical to all those others. And you can see that I can, you know, this does not stop me from, you know, interacting with everything else as usual. It just finds another solution, usually one that's inside that unit circle. So, therefore, I would say it's fine. Programmatically, if you want to increase this, like just have something that increases the angle by 1 degree every frame or 10 degrees every frame, it's not like you have to check to make sure that if it's above 180, set it to -180, otherwise everything will break. It's not going to break, you can see, right? Go.engine, I noticed, also does this. They don't go past 180 degrees with gizmos and stuff like that, right? But everything else that I could find does. And so I just chose this kind of solution because it just happened to be really simple, as you saw, and everything seems to work fine. Okay, so that's that. Look at me trying to switch gizmos as if it works. Let's make that happen, eh? So to switch gizmos, we should just add a little, key code thing here. So at the end of these things, let's add our gizmo shortcuts. So I'll do gizmos. So case key Q. So Q, I kind of like these controls, Q, W, E, R. So these are from like, I think most 3D programs, but I remember this in like 3D Max and Maya and everything really. Blender just has their own kind of, you can use G to just move stuff without having to use gizmos, and I don't think their gizmo shortcuts are the same here. But Q is kind of your selection tool, so it's just nothing. W is translate, E is rotate, R is scale. So it's kind of like Q, W, E, R. Your kind of select, and then TRS, translate, rotate, and scale. So this is as simple as just setting the gizmo type to -1 if it's Q, because that's our selection tool. That's no gizmo at all. And maybe in the future when we have tools, we'll rewrite this. And also these maybe should be customizable shortcuts as well, but whatever for now. W is translate, so we'll set it to ImGuizmo operation translate. And then obviously this is going to be rotate and scale. So scale, rotate. Isn't this just all really easy? I love it when programming is just as simple as adding that stuff in a matter of seconds, you know? It's good. It's always good when you write code like that. Now, none of this works because I am still setting it every frame. So let's remove that. Someone said that's why most engines use radians. I'm using radians as well. It has nothing to do with radians. Radians are just a different unit. It's kind of like meters versus centimeters, right? Or I guess Celsius and Fahrenheit, although that's a bit different. There's a direct conversion between, an easy conversion, I'll say, between radians and not radians. It's the same thing, it's just a different unit. We're storing everything in radians. We're only converting to degrees for this view here. So if I look at pink cube, that took me too long. This view here is in degrees, but internally it's all storing this in radians. Like if I look at, I guess this is fine. Where's my transform component? Here, you can see that the rotation for the selected entity is 0.78. That's equivalent to 45 degrees, I think. So it is actually in radians, right? It's this one here. 45 degrees. Okay, anyway, yeah, so now, right, Q, you can see, gets rid of the gizmo entirely. W, E, R. Beautiful, let's test out scale. Works perfectly fine. We should be able to move this somewhere now. Let's move it over here. We can rotate it wherever we want. We can scale it non-uniformly. Everything seems to be fine, right? We can scale it to 0 and everything's fine, doesn't break. And then scaling it up will take a little bit of time, but there we go, right? Everything seems to work. So you guys can play with this and try and break it, and then we can fix any bugs that come out of it. But for the time being, as you can see, I think I'm pretty happy with it. Now, the last thing that we're going to add, this is a long episode, isn't it? We haven't had one in 43 minutes. Okay, good. I'm happy. This makes up for like the fact that we haven't, big juicy episode makes up for the fact that we haven't done an episode in ages. The last thing that I'm going to do is add snapping to this, right? So if I hold the control key down, I want to basically snap to angles of 45 degrees or like to maybe 0.5 meters if I'm translating or scaling. Now, pretty easy to do. This should be configurable in the UI. Maybe you don't want to snap to 45 degrees. Maybe you want to snap to half of that. Maybe you want to snap to 90 degrees. I don't know. It's totally something that you should be able to customize, I think. So what I'll do, and why do I have this? There we go. This was like a little hand cursor for ages. See, every program has problems, so don't be too harsh on Hazel. So what we'll do is maybe over here we'll deal with snapping. So first of all, whether or not we're snapping is going to directly depend on whether or not at the time of us rendering the gizmo is key pressed. and we'll just say the control key, I think, left control, right? So that's if snapping is enabled or not. Now the snap value, that's what you want to snap to. We'll set to 0.5. However, totally going to depend on the tool, right? So 0.5 might be good for translation and scale, but for rotate, 0.5 degrees, bit silly, right? So what we'll do is we'll say, I could write this as like a ternary, you know, but this will probably be easier. If ImGuizmo type equals ImGuizmo operation rotate, snap value equals 45. Snap to 45 degrees for rotation. Snap to 0.5 meters for translation scale. So Hazel uses meters for units, in case that's not already clear. I think most game engines probably do. Okay, so we have a snap value. Beautiful. Now we actually need to create like a little float array out of it so that we can do it for X, Y, and Z. Because you can actually, ImGuizmo lets you set a different snap value for each axis, but that's probably not that useful most of the time. So snap values, and then we'll just do snap value, snap value, snap value, because that's what ImGuizmo wants. And then we just pass in snap values into manipulate if we need them. So this I think is a delta matrix, which we'll leave at null pointer. And then if we're using snap, we'll pass in our snap values. Otherwise we'll pass in null pointer, and that should in fact be our snap argument, and it is. All right, so hopefully now if we hold the left control key down, we will snap. Now obviously this will snap based on where you currently are. It's not gonna be like a world snap. Maybe that'll be a good feature as well. But ultimately what this means is that if I'm at 0.6 and I try to translate with snapping, it'll move me to 1.1, not to 1 or to 0.5. So if I select like this one and I move and then I hold control, hey, you can see that I now snap to place. And you can see over here that I'm at 0.35x, and if I hold control, and by the way, you can start moving, but then halfway through hold control, which I really like, because you can see that's perfect. And you can see that this is a 1x1 quad, so 1x1 meters, which means if I do 2 increments with snapping on, I'm perfectly at this edge, and you can see the math here work out. Perfectly might be slightly incorrect or whatever. No, actually, I don't think it was that. It was this is displaying to because you can see that's a bit off now. This was displaying to 2 decimal places, which was not which is not obviously that accurate as what it actually is. Because I think if I load that again and we look at this one, well, it's still displaying to 2 decimal places here. Anyway, whatever, I give up. Anyway, there we go, that works. And with rotation, again, if I start rotating, hold down control, there's your 45 degree increments, and you can see the degrees drop here. Even shows it up in radians as well, which is nice. All right, beautiful. So we've got snapping. What more could you want? Perfect, right? So there you go. That is Gizmos implemented. What do you think, chat? Stream, you happy? Let's bring the chat in. The chat's gone. I deleted it. That's a bit unsettling. It's back though. All right, so that's that, right? It's really not that difficult when you're using a third-party library that you have already modified to look nice and to you know, to work like you want to, and you've spent the time to work this stuff out, and you have your own decompose function, and everything else has already been done for you. It's pretty easy, but that's basically it. I'm gonna quickly look through the diff to see if I missed anything. Oh yeah, one thing that is really annoying that I noticed is that basically the way that this is set up at the moment is that if I, well, first of all, let's just try and activate a gizmo here. Okay, doesn't matter, it's not gonna crash or anything, which is good. If I load pink cube, this is really annoying. I'm the right gizmo here, right? I've clicked on left to select it. WER doesn't work. Even when I'm hovering over the viewport, WER doesn't work until I click, and then it works. Now this is already a problem because when we have mouse picking, we can't just click arbitrarily on the viewport because that's also going to probably do a raycast and pick an object. So that's super annoying. And the reason this happens is because I'm a fool who accidentally doesn't understand how logic works. and wrote this little piece of code here. So when we block events, I did viewport focused or viewport hovered is both false. What we want is to only block events if neither viewport focused nor viewport hovered is true. So in other words, if you're neither focused on the viewport, nor are you hovering over it. So actually this should be and, because what we're looking here is we want this to be false if either of these are true. And obviously they have to both be true for this to be true, and thus block events is true. So yeah, a little bit, sometimes they can be a little bit annoying, these things. Okay, so now if I do this, basically it's a really subtle thing, but now the cool thing is if I do this, right? WER not working because I'm hovering over scene hierarchy, but as soon as I don't have to click on it, as soon as I hover, there you go, see? It immediately gets set as long as I'm over the viewport. I think that's how Blender works as well. But you can decide how you want to do this yourself. In Hazel Dev, we have something a bit more sophisticated because I think that if like you're maybe typing the name here, but you're hovering over here, you can see it still changes. And you can actually fix this by seeing if ImGui has the focus of a particular control. We're not going to cover that today. Hazel Dev does that though. But yeah, otherwise there you go, Gizmos, knock yourself out. Yeah, they'll always be dependent on, I think, the size of the screen. So you can see they're kind of small here, but you're not really going to be doing that. And then here they get kind of big. So they're kind of in the screen space size, I guess. But yeah, that is your whole Gizmo situation. And as you can see, everything seems to work pretty well. And that is Gizmos. So hope you guys enjoyed this video. If you did, please do not forget to hit the like button or subscribe on Twitch. Patreon.com/thecherno is the best way to help support this series and also get access to the Hazel Dev code, which is really exciting. Take a look at the latest Hazel Dev log. I'll have it linked up there as well. We've got like shadows now, and I'm working on some other really exciting stuff that I can't wait to reveal. So everything's going really well, doing tons of work on this. We've got a wonderful community of people, and I'm so happy with everything that we have been able to achieve. And thank you so much to all of you for your support and just helping to make all of this possible. It's just amazing. All right, next time, what I don't even know what we're gonna do next time. I never know because we've done like this now. Oh, we should look at the roadmap. We'll look at the roadmap at the beginning of next episode and decide what we're doing. Don't forget to follow on Twitch as well if you want to catch the latest live streams, and Twitter as well because I usually announce live streams there. I will see you guys next time. Goodbye.